Now, next session is lecture and lab tour by Professor INAMORI, titled Visit to Power and Communication Lab. Professor INAMORI is in her laboratory now. Let's see where she is. Professor INAMORI, can you hear me?
Yes, I'm here. I can hear you. Hi, everybody. I'm at the TechnoQ. So can I start? Okay. So today I will introduce our research lab. I'm Mamiko INAMORI from Tokai University. So let's get the lab tour started. Here are the contents of today's lab tour. Our lab is doing the research of power and communication to contribute the energy saving infrastructure. Currently, we have two research topics, which are signal processing for wireless communication and wireless power transmission. We are doing the research of wireless communication itself for like Wi-Fi, 5G, something like that. But today, we focus on just wireless power transmission. After I talk, my two students are explaining their own research. Then we show the demo. First of all, I'll talk about the wireless power transmission. Wireless power transmission is a promising technology and it's expected to see wide adaptation in mobile devices and electric vehicles like EV. This figure shows the relationship between the distance and then transmitted power of three scales. If the efficiency and the distance becomes large, the opportunity to use this wireless power transmission is increased more. So in the three methods I show, like research for wireless power transmission by magnetic resonant coupling method has been studied extensively. As the method of wireless power transmission, magnetic resonant coupling method is applied to our system. We use that method. High efficiency can be achieved over a long distance with this magnetic resonant coupling method. In the system, to evaluate the system itself, power efficiency is very, very important. To calculate the power efficiency, we need to measure the input power and output power, which are shown in this figure. You see the input power and output power in the both circuits. The power efficiency is defined like this. It's very simple equation. So we measure the power and then calculate the power efficiency. For better wireless power transmission system, high efficiency can be achieved over a long distance. The efficiency starts to decrease gradually at a certain distance. So we have reported on analysis, loss analysis in a short distance. The loss of sending circuit and receiving circuit can be divided into diode loss and capacitor loss. So the cause of efficiency decrease in a long distance need to be investigated. So we are figuring out the reason with the various perspectives, such as circuit, material, and even the medium between antennas. So I explain more about medium. We also apply the wireless communication to the wireless power transmission system. In wireless power transmission system, power efficiency is affected by distance between antennas and load at the receiving side. To achieve the high efficient wireless power transmission system, reliable data communication is necessary to adapt system parameters and no conditions at the receiving side, like this. So this is very unique research topic. and the details are explained by my students. So let's see the detail of research topics. So I introduce my students. Please go.
Hello, my name is Satoshi Shitai from INAMORI Lab. I will talk about my research. In recent years, robots such as AUVs have been used on the bottom of the sea for carving and working on the seafloor. After the AUV leaves from the vessel, since the battery is consumed to work independently, AUV have to surface of the sea and recharge the power if the battery storage become low. By extending power cable from work vessel into seawater and performing contactless power transmission in seawater, the need to flow is eliminated. Oceanographic data is used to determine electrical conductivity and water temperature at the bottom of the sea and at the sea surface. This figure shows the Bosemal, a research and training vessel by the university. Let's look at the results obtained with this vessel. This figure shows the data measured at 4 locations in Suruga Bay. The horizontal axis is water depth and the vertical axis is water temperature. Water deeply. On the parameters that changes significantly by the changing of water temperature is electrical conductivity. This figure shows the relationship of electrical conductivity in seawater and water temperature. Next, we will experiment with contactless power transmission in seawater. First, a waterproof coil was made to transmit power as electromagnetic waves. This figure is 1. Now, we will examine the actual effect of contactless power transmission. We will vary the water temperature and perform contactless power transmission in seawater. Experimental conditions were set as follows. Next, the experimental configuration is described. The left figure shows the circuit diagram of the experimental device. As shown on the right, seawater is filled into the water tank of the experiment. Here are the results of the experiment. Here is a diagram of the total loss. This figure shows the total loss is increasing due to the degrees in water temperature. That in seawater, efficiency is reduced due to various factors. Our research is aimed at solving these problems. Thank you. Ramadan will be present
Hello everybody, good afternoon. My name is Ramadan Nur Adabi. I am from Indonesia. And today I will talk about my research topic, that investigation of data transmission for wireless power transfer system in seawater. First, I will tell you about the background and motivation why this research is very important in our laboratory. Wireless power transfer system that can send power easily without cable is becoming very popular in recent years. Wireless power transfer system has also developed in seawater condition as there is a high efficient for the wireless power transfer system. Wireless power transfer system also developed to charging technology device such as for mobile phone, smartphone, etc. And with the advantage of not having used cable and physical contact, the wireless power transfer system will offer a high safety for charging electronic device underwater or autonomous underwater vehicle. In wireless power transfer system, there are two main parts, which are coil antenna will affect between this antenna. When the distance between this antenna becoming higher, the power efficiency becoming lower. And data transmission is necessary for wireless power transfer system to maintain the stability and efficiency for the transfer power. This data should be transmitted quick and reliable way. Okay, that's about the background and motivation. Next, I will tell you what I'm really doing in our laboratory. My purpose in this research is to investigate the effect on bit error rate performance of data transmission for wireless power transfer system in seawater due to change in the distance between the antenna and change in the load on the receiver antenna. Okay, that's what I'm doing in the laboratory. Next, I will tell you how I'm doing my research in this lab. So, in this study, the wireless power transfer system is designed using solenoid single coil antenna made from polyester copper wire with a diameter of 1.6 millimeter, as you can see in this table. So, and also to make it solenoid coil antenna, the coil is turned around 30 times along the pipe. And to make it waterproof, the solenoid coil are coating by silicone with the thickness of 2 millimeter. And with this model of antenna, we can get the number of inductance on the transmitter is 153.069 microhenry, and the number of inductance and the receiver is 151.883 microhenry. To achieve the magnetic resonance coupling method, both coil antenna should have the same self-resonance coil. This resonance is depending on the number of inductance and number of capacitance distributed on the transmitter and receiver antenna. Then, we using this device, impedance analyzer IM3590, to measure the impedance on the antenna. And with the frequency resonance formula, we calculate the number of capacitance to get resonance coil at the 85 kilohertz. This table is shown the experimental condition. We connected the 22.9 nanofarad capacitance to the transmitter antenna and 23.1 nanofarad capacitance to the receiver antenna. Also, we set the distance between the antenna is 1 centimeter, 5 centimeter, and 10 centimeter. And on the receiver antenna, we add variance load as 10 ohm and 30 ohm. After that, this antenna is submerged into 3% of saline water, which is seawater. And we are using this device, vector network analyzer, to obtain the transfer function between the antenna. And this is the experiment model is described in this figure. Both of antenna are submerged into the seawater. Capacitance are connected to the resonance coil to get the same self-resonance coil, and the experiment results are observed in the vector network analyzer. And this is the result of the experimental condition, experimental in the research. From this experiment graphic, we can see that this figure shows that the power transfer efficiency becoming lower as the distance between the antenna is increased. And also from this figure, we can see that the power transfer efficiency becoming lower as the load on the receiver antenna is increased. Now, after get the result of the experimental, we continue to make a simulation. To investigate the data transmission for wireless power transfer system in this experiment, the computer simulation is performed with MATLAB. And this table is shown the simulation condition. And this is the simulation result using the MATLAB. As we can see in this figure, both of this figure, it shows that the bit error rate performance will be worse as the distance between the antenna is increased. It is because power efficiency decreases when the distance between the antenna is increased. And also from this graph, we can see that the bit error rate performance becoming worse as the load on the receiver antenna is increased. It is because power efficiency decreases when the distance between the antenna is increased. Okay, finally I will show you the conclusion. Data transmission for wireless power transmission system has been investigated in seawater. The distance between the antenna is one of the factors that affect the power efficiency. Power efficiency becomes lower as the distance between the antenna is increased. And the load on the receiver antenna is one of the factors that affect the power transfer efficiency. As the load on the receiver antenna is increased, the power efficiency will be decreased. Okay, now let's see the demonstration. As we can see here, we have two solenoid coil antenna. What we will do is we will show that this antenna will transfer power wirelessly, but we will block the wireless transmission here with the paper and with the bronze. Now with the paper. As we can see here, in the light, this is LED. When we block the antenna with the paper, nothing happens with the light. But when we want to block with the bronze panel, as we can see here, the light will be turned off. It is because the magnetic field is blocked with the bronze panel. So it will cut off the transmission. And next experiment is we will change the distance between two antennas. When a distance becoming higher between the antenna, the light will be turned off because the wireless power cannot transfer to the another antenna. But when the distance between the antenna is closer, so the light is becoming glow, becoming turned on because the wireless transfer successfully. Okay, that's about our laboratorium.
For joining us. Thank you very much for your interest in Tokai University. Okay, we will waiting for you. Please join.
Yay.
Bye.
Thank
See you in our
you.
laboratorium.